Okay, so today we're going to finish up the notes on section 1.6b. We're going to continue solving radical equations and other types of equations in this lesson. Remember, we need to check our answers on these radicals. So the check here is mandatory. So I did the first 6 examples. Remember, your first step is always going to be isolate a square root. If you have more than one square root, you're going to have to do these steps twice if there's 2 radicals. But if it's only one square root, you would only isolate it once, square it, and then solve what remains. But if there's 2 square roots, we'll have to do this process twice. And that's what we're going to see when we get to example number 7. So notice here, I've got 2 square roots. Again, your first step is always going to be to isolate one of the radicals. And if you notice already, the right side's already isolated. So I'm just going to go ahead and start my squaring process. So let me go ahead and just rewrite this. So x plus 5, it's under the square root, minus 2 equals x minus 1. So remember, in order to get the radical to disappear, what we need to do is square both sides of our equation. However, remember, when we're squaring this left side, we got to FOIL it. So let me come over here because sometimes these are a little tricky. So I'm going to go ahead and write it down 2 times, and I'm going to FOIL it. So once I do first, remember the radical will disappear. The x plus 5 comes out. Then when I do the outer, I get negative 2 times the square root of x plus 5. Same thing for the inner terms here. I get negative 2 times the square root of x plus 5. And then finally, when I do last, negative 2 times negative 2 is positive 4. I'm going to go ahead and combine my like terms. So these middle guys get combined, and I get negative 4 times the square root of x plus 5. And then I also have like terms here with the 5 and the 4. So then that'll give me plus 9, and then nothing to combine with the x. So x plus 9, and then minus the 4 times the x plus 5. So now let me go ahead and write that over here. So this is this thing FOILed. So x plus 9 minus 4 times the square root of x plus 5. And then the right side, squaring that radical just makes the x minus 1 come out. So now, I still have a radical, a square root in my problem. I need to isolate it. So I need to move the x to the other side. And notice when I try to get my x's together, it just cancels on both sides. So now I'm left with 9 minus negative 4 times the square root of x plus 5 equals negative 1. And then next I'm going to move the 9 over. Negative 4 times the square root of x plus 5 equals negative 10. Now what I need to do is get rid of the radical. So I'm going to square both sides. So I'm going to square the negative 4, which makes it become positive 16, and then the radical disappears. And then I have to do negative 10 squared, which gives me 100. I'm now going to go ahead and distribute, and I get 16x plus 80 equals 100. I need to subtract the 80. I get 16x equals 20. Divide by 16, and x equals 20 over 16. I need to reduce. I can divide them both by 4, and it reduces to 5/4. Remember, you must check this answer. So I'm now going to plug in 5 over 4 into my original problem. So this is my check. So x plus 5 under the radical minus 2 is equal to x minus 1 under the square root. So 5 over 4 plus, and I could put a 1 under the 5, minus 2, 5 over 4 minus 1. So I need to simplify what's under the radical. I'm going to make the whole number 5. I'm going to change that into 20 over 4, so it has a common denominator. Same thing over here. I'm going to change that whole number 1 into 4 over 4. I'm subtracting there. So then I get 25 over 4 minus 2 equals 1 over 4. I can now square root. Remember, you could do it separately, so this becomes 5 over 2 minus 2, and then this becomes 1/2. And then 5 over 2 is really 2.5, and then this gives me 1/2, and 1/2 equals 1/2, so it checks. So 5 over 4 is a good answer. So the final answer here is x equals 5 over 4. Number 8, we're going to do exactly the same thing. We need to isolate the radical, so we're going to square both sides. You good on 7? Go to 8. Okay, so for 8, again, let me just rewrite it. So 4x plus 1 under the square root equals x minus 1 under the square root plus 2. I need to square both sides. Squaring the left side just makes the 4x plus 1 come out. I need to FOIL the other side. So when I FOIL it, x minus 1 plus 2, x minus 1, the square root of it, plus 2. So when I do first, I get x minus 1. When I do the outside, I get 2 times x minus 1. When I do the inside, I get 2 times x minus 1. And then finally last, 2 times 2 is 4. I'm going to add the middles. This gives me 4 times the square root of x minus 1. I can also combine my like terms here, the -1 and the +4. Nothing to combine with the x, so then x plus 3 plus 4 times the square root of x minus 1. Let me go ahead and put that down here. Yes. So this side now is x plus 3 plus 4 times the square root of x minus 1. I now need to isolate this radical again, this one, this time. So I'm going to move the x over. And then this gives me 3x plus 1 equals 3 times, or 3 plus 4 times the square root of x minus 1. I now need to move the 3 over. And then now this will give me 3x minus 2 equals 4 times the square root of x minus 1. I now need to isolate. So it's isolated, so now I square both sides. I'm foiling the 3x minus 2. So once I FOIL that, I get 9x squared, and then I'll get -6x, -6x, so -12x plus 4. And then the right side, square the 4, and then the x minus 1 comes out. I need to distribute the 16. I'm just going to rewrite the left side. 16x minus 16. I now need to get my like terms together. So I'm going to subtract the 16x. I get 9x squared minus 28x plus 4 equals -16. I need to add the 16 now to both sides. And now I get 9x squared minus 28x plus 20 equals 0. I now have a trinomial that I need to factor. Now, you can either factor it by grouping or you can guess and test. So if I factor this by grouping, I would be multiplying 9 and 20 So I'm looking for two numbers that multiply to give me 180, but who will add to give me negative 28. So this one's kind of large, but again, it's doable. So notice it's negative 28, but a positive 180. So that tells me my signs are the same. So my factors of 180 are going to be negative 1 times negative 180, negative 2 times negative 90, negative 3 times negative 60. Notice none of these are giving me negative 28 yet. Negative 4 and negative 48, negative 5, negative 36, negative 6, negative 30, negative 9, negative 20, and then finally negative 10 and negative 18. Now, you could have also guessed and tested. It's actually going to be the factors of 9 are going to be 9 and 1, and the factors of 20 would be 10 and 2 if you wanted to guess and test. But then you'd have to FOIL it. But I'm going to do grouping. So rewrite the first term. Replace the 28 with the two factors you just found. So I'm going to put in a negative 10x and a negative 18x. Again, it doesn't matter the order that you place them in here. Now make your two groups. Look for your GCF. My GCF of the purple group is going to be x, so 9x minus 10. My GCF of the red group is going to be negative 2, and then you're left with 9x minus 10, and then it's equal to 0. So now set each of the factors equal to 0. So put that one together along with what was in common, the 9x minus 10. Now set each of the factors equal to 0. Add 2. First answer potentially is x equals 2. And then the second one, add 10. Then divide by 9. And x equals 10 over 9. Now, if you're good at guessing and testing, and you just wanted to try to take the factors of 9 and the factors of 20 that FOIL together, you could have skipped the factor by grouping. Whatever works for you. Now, this is, again, a mandatory check, so we have to check these two answers. So let me go ahead and do the check now. Yes. Okay, so I'm going to check my answer. I'm plugging it into the original, and the original was the square root of 4x plus 1 equals x minus 1 under the square root plus 2. So I'm going to plug in 2 first. So once I plug in 2, 4 times 2 plus 1 equals 2 minus 1 plus 2, and that's under the radical. 8 plus 1, I get the square root of 9. Here I get the square root of 1. Square root of 1 is 1. And then square root of 9 is 3. 1 plus 2 is 3. So this checks. So x equals 2 so far is a good answer. And now I need to check the 10 over 9. So again, I'm plugging it into the same original equation. So 4 times 10 over 9 plus 1 equals 10 over 9 minus 1 plus 2. So here I'm going to multiply. I get 40 over 9. I'm also going to change my whole number 1 into 9 over 9 because I'm going to have to eventually subtract that. Same thing here, 10 over 9 minus 9 over 9. So then this gives me 49 over 9. This one gives me 1 over 9 plus 2. 49, when I square root it, it's 7. When I square root the 9, it's 3. And then here, the square root of 1/9 is 1/3 plus 2. And you can either make this into a mixed number, and you get 2 and 1/3, and this one's 2 and 1/3. Or you could have added this and found a common denominator. You could have done 1/3 plus 6 over 3 and get 7 over 3. And then you could have gotten 7 over 3 equals 7 over 3. Just rewrite it down here. Either way, it checks out. So both positive 2 and 10 over 9 are good answers. So next it says, if it's any root other than a square root, we're just going to raise it to the same power as the index. So if it's a cube root, we're going to raise both sides to the third power. If it's a fourth root, raise both sides to the fourth power. If the expression is raised to a fractional exponent, a rational exponent, then we're going to raise it to the reciprocal power. So let's go ahead and try some examples of these. So for the first one, notice it is a cube root. First step, isolate. So we got to isolate the radical. So we're isolating the cube root. So I'm going to add the cube root of x to both sides. And now I'm left with 4x squared minus 4x plus 1, still under the cube root, equals the cube root of x. So the little 3, the cube, is going to be my index. So in order to solve this, I have to raise both sides to the third power, and that's going to eliminate the radical on both. So it's canceling this radical. And now I'm left with solving 4x squared minus 4x plus 1 equals x. I need to get this into a trinomial, so I'm going to subtract x and set my equation equal to 0. And now either I can guess and test here, or I could factor by grouping. This one's probably easy to guess and test because 1 only has 1 times 1 as the factors, and 4 would be 4 and 1 or 2 and 2. But I know a lot of you like the grouping, so I would be multiplying the first and the last. So I'm looking for two numbers that will multiply to give me 4, but who will add to give me -5. So 4x squared. And then it doesn't matter, so this is going to be, it's not 2 and 2, it's going to be 1 and 4, but they both have to be negative. And it doesn't matter how you put them in here. You can either put it in with the 4 first or the 1. It doesn't matter. So if I put 1x and then put in the -4x plus 1. If you want to put the 4 first because you see it looks like the first one, you can. Doesn't matter. You get the same answer either way. So my GCF of red is x. I'm left with 4x minus 1. GCF of blue is going to be -1. And then my signs flip. So now I take the two GCFs, they go together. And then the one that's in common, the 4x minus 1, is the other binomial. Set each of the binomials equal to 0. The first answer is x equals 1. The second one, add 1. Then divide by 4. And the second answer is x equals 1/4. Now I have to check. So now I'm going to go back, do my check over here. So the original problem was 4x squared minus 4x plus 1 under the cube root equals, no, minus the cube root of x equals 0. So let me put in, I'll do the 1 first. So 4 times 1 squared, 4 times 1 plus 1, and that's all under the cube root. And then minus 1, the cube root of 1. So here, simplify what's under the root. And then this gives me the cube root of 1. The cube root of 1. Cube root of 1 is 1. So 1 minus 1 is 0. So x equals 1. This one works. So now I got to plug in 1/4. So let me do that one. So the check here, 4 4 times 1/4 squared minus 4 times 1/4 plus 1 plus the cube root of 1/4 equals 0. So let's simplify what's underneath here. This ends up becoming 1/16 times 4. So 4/16 minus 1 plus 1 plus the cube root of 1/4 equals 0. So then here, notice this 1 minus 1 is gone. And then I'm left with, I can simplify this, 1/4 cube root of 1/4. Now, at first glance, you're thinking, how can I find the cube root of 1/4? If you just recognize that you're just subtracting the same root minus the same root, this is 0 equals 0, so it checks. You don't actually need to figure out what the cube root of 1/4 is. Just know that you're subtracting the same root from it, so you get a 0. So x equals 1/4 is also a good. Okay, so for number 10, notice this one's raised to a rational exponent. Really, the 1/3 power is really the cube root here, but I'm just going to leave it with a fraction exponent, and I'm just going to raise it to the reciprocal power. But I got to isolate first, so I'm going to go ahead and add 4x plus 2 raised to the 1/3 power to both sides. So now I'm left with solving 3x plus 7 raised to the 1/3 power is equal to 4x plus 2 raised to the 1/3 power. So now to solve, I'm going to raise both sides to the reciprocal power. So the reciprocal of 1/3 is just 3/1, or just 3. So that's going to cancel this power. And now what's left is just solving. 3x plus 7 is equal to 4x plus 2. I need to get my x's together. And it doesn't matter if you move the 3 over to the 4, or you move the 4 like I did over to the left side. Subtract the 7. I get negative 1x equals negative 5. Divide by negative 1, and x equals positive 5. Now I got to do a quick check here. So my check, I'm going to go ahead and plug in 5. So 3 times 5 plus 7 raised to the 1/3 power minus 4 times 5 plus 2 raised to the 1/3 power equals 0. So 15 plus 7, raised to the 1/3 power, and then here 20 plus 2 raised to the 1/3 power. So 15 plus 7 is 22. 20 plus 2 is 22. Notice again, I'm just subtracting the same thing by the same thing. I don't need to figure out what 22 to the 1/3 power is. When you subtract it by itself, you get 0. So x equals 5 is a good answer. It checks. So for number 11, notice the index here, this little number is 4. So in order to solve this one, I need to raise both sides to the 4th power instead of squaring it. So you raise both sides to the power equal to the index. So let me just rewrite it here. And this is the 4th root. So I'm going to raise both sides to the 4th power. So once I raise this side to the 4th power, it cancels the root. So now you're just left with x squared plus 6x. And then I have to do 2 to the 4th, which is 16. I now need to move the 16 over and set my equation equal to 0. So now I get x squared plus 6x minus 16 equals 0. I have a nice easy trinomial to factor. I'm looking for the factors of negative 16 that give me positive 6. and those factors are going to be positive 8 and negative 2. Set each of the factors equal to 0. So x plus 8 equals 0, x minus 2 equals 0. Subtract the 8, x equals negative 8. Add the 2, x equals positive 2. And now I have to check. So I'll check x equals negative 8 first. So negative 8 squared plus 6 times negative 8. And I'm going to see if that's going to equal 2. I get 64 minus 48. 64 minus 48 is 16. And I'm doing the fourth root, not the square root. And the fourth root of 16 is 2. So this one checks. Then I also have to plug in a positive 2. So 2 squared plus 6 times 2. And again, it's under the fourth root. And then 4 plus 12, 16. And again, the fourth root of 16 is 2. 2 equals 2. This one also checks. So x equals negative 8 and x equals positive 2 are both good answers. Next one is raised to a power of 1/4. So I'm going to raise both sides to the reciprocal power. And the reciprocal of 1/4 is positive 4. Try this one. So again, let me rewrite. 3x squared, 52x raised to the 1/4 power equals 4. So in order to get rid of that power, I'm going to raise both sides to the 4th power. So that will cancel this because it just becomes a 1. So then now I'm left with 3x squared plus 52x. And then 4 to the 4th is actually 256. 4 times 4, 16. 16 times 4 is 64. 64 times 4 is 256. So now I'm going to subtract the 256. 3x squared plus 52x minus 256 equals 0. Now, kind of large. We could factor by grouping, or we could guess and test, because the factors of 3 are just going to be 3 and 1. And then it would just be the matter of finding the factors of 256. But let me go ahead and do factor by grouping, because I know so many of my I period loves factor by grouping. So I'm going to multiply 3 and negative 256, and I get negative 768. So I have to find two numbers that'll multiply to give me negative 768, but who will add to give me 52. So if I start my nice organized list here, negative 1 signs have to be different. And the bigger factor will be the sign of the middle. So the bigger factor is positive. And then negative 2 times 384. And then negative 3 times 256. Negative 4 and 192. Negative 6 and 128. Negative 8 and 96. Still not there. I'm getting close. And then finally 12 and 64. And that's going to be my combination. So then now I'll rewrite the first term, replace the 52 with the factors I just found. So then negative 12x and the positive 64x. And again, it doesn't matter the order you put them in here. And now I need to make my groups. Blue group, purple group. GCF of blue is going to be 3x. GCF of purple is going to be 64. Take the two factors, the two GCFs, put them together. And then the factor that's in common. Now again, if you would have preferred to guess and test and just do the factors of 3, which were 3 and 1, and then the factors of 256 and then just start foiling until you found the one that worked, you could have jumped from this step without doing the grouping if you did the guess and test. But if you do guess and test, you got to foil it and make sure it does go back. So now that I found the two binomials, you're going to set each of them equal to 0 and solve for x. So subtract 64. 3x equals negative 64. Divide by 3. And my first solution is negative 64 over 3. And this one just gives me positive 4. So now I need to do the check. So I need to plug them both in. So I'll go ahead and check the negative 64 over 3 first. So 3 times negative 64 over 3 squared plus 52 times negative 64 over 3 raised to the 1/4 power equals 4. So I'm going to go ahead and square this 64 over 3, and I get 4,096 over 9 times 3. And then over here, when I multiply this, I get 3328 over 3 negative equals 4. And then I can go ahead and multiply here and add, and I get 768 over 3 raised to the 1/4. And then I can go ahead and divide this, and I get 256. And then 256 raised to the 1/4 power. Remember, this is finding the 4th root of 256, which is 4. So this one checks. Then for the next one, I need to plug in positive 4. 3 times 4 squared, 52 times 4. All of this is raised to the 1/4 power. 3 times 16. And then if I multiply this, I get 208. And then when I combine this, I get 256. This will give me 48 and 208. So 256, again, raised to the 1/4 power. And the 4th root of 256 is 4. So this one also checks. So my two answers I found, negative 64 over 3 and positive 4, both work. Number 13. In order to solve this, I'm going to raise both sides to a reciprocal power. So what I'm going to do is raise both sides to the 5th power. So let me go ahead and rewrite the problem. So I'm going to raise both sides to the 5th power. So that's going to cancel this one, and then this one simplifies. So then this one just becomes x minus 3 squared equals 4x. I got to FOIL the x minus 3. It becomes x squared minus 6x plus 9. I need to move the 4x to the other side, set it equal to 0. X squared minus 10x plus 9 equals 0. Factors of positive 9 that give me negative 10 are going to be negative 1 and negative 9. Set each factor equal to 0. Solve for x. I'm going to add 1 on this one. X equals positive 1. Going to add 9. X equals 9. Again, I got to check, so I'm going to plug them in. So for the check, you're going to plug in 1 minus 3 raised to the 2/5 power equals 4 times 1 raised to the 1/5 power. I get negative 2 raised to the 2/5 and 4 raised to the 1/5. So here, this just becomes, if you think about it, you can apply the exponent. So then it becomes, if you just square it, and then you get 4 to the 1/5 power equals 4 to the 1/5 power. Don't worry about figuring out what it is. It's equaling to itself. And then the same thing on the 9, plug it in. 9 minus 3 raised to the 2/5 equals 4 times 9 raised to the 1/5. And then here we get 6 raised to the 2/5 equals 36 raised to the 1/5. And again, square the 6. And then now it's just raised to the 1/5, which is the other side. So this one also checks. So both answers we found are good. And then the last example, I'm going to raise both sides to the 4th power. So if I raise both sides to the 4th power, that cancels that fraction, and this simplifies to an x squared, and then I get 3x to the 3rd. And then also know this was also, actually this is raised, the whole thing is raised to the 4th. So then here what we need to do is make this an 81x to the 3rd equals x squared. I need to subtract the x squared. I get 81x cubed minus x squared equals 0. I'm going to factor out a GCF of x squared. I'm left with 81x minus 1 equals 0. Set each factor equal to 0. So this one is just x equals 0. Here, you get 81x equals 1, divide by 81, and x equals 1 over 81. I'm going to go ahead and plug them both in. They both will work. So you're squaring this whole side of this equation and raising, or not squaring, you're raising both sides of the equation to the 4th power.
Could you have raised it to the 2nd power?
So let's do the check. So now I'm going to plug in both answers. So once I plug in 0, 3 times 0 raised to the 3/4 power equals 0 raised to the 1/2 power. This just becomes 3 times 0. 0 equals 0. That one works. And then here, 1 over 81 is going to be raised to the 3/4 power equals 1 over 81 raised to the 1/2 power. Remember, raised to the 1/2 power is really like doing the square root of 1 over 81. And then what here I can do is I'm going to go ahead and take care of the root here first. So I'm going to cube root, or not cube root, find the 4th root of 81. So this will give me 1/3. And then I can cube it, and I get 1 over 27. This one is just going to give me 1/9. And then this gives me 3 over 27, which reduces the 1/9. 1/9 equals 1/9, so it checks. So x equals 0 and x equals 1 over 81 are both good answers. So your homework is on WebAssign. It is the 1-6B homework assignment due tomorrow. And then tomorrow we're going to cover rational equations, which we already covered in the prerequisite chapter, and absolute value equations.